Okay, so today we're going to move on to our next shape doing coordinate geometry proofs. We are going to prove a rectangle in coordinate geometry. So please make sure that you take out a piece of graph paper and a piece of loose leaf paper if you chose not to print out these notes. So the first thing that we need to go over are the properties of a rectangle. Now, a rectangle has all the properties of a parallelogram. Whoops, sorry about that. So if we list them quickly down here, our opposite sides are congruent. The opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. And the diagonal creates two congruent triangles. Now, what makes a rectangle different from a parallelogram is that it has 4 right angles. So we can mark up our picture with 4 little boxes. And the diagonals are congruent. So if I drew a line, AC has the same length as DB. So now if we wanted to prove that something is a rectangle in coordinate geometry, first we're going to prove that it's a parallelogram. And when we did this the other day, we did that the opposite sides were congruent, so we did 4 distance. And then to make it foolproof for those of you, we're going to do this one here. So to show that the diagonals are congruent, we're going to do 2 more distance. There are other ways to do these proofs, but I'm trying to make it as easy as possible. And when we do many of these proofs, you're going to say in your head, when in doubt, distance it out, because the distance formula works for almost every shape. So if we look at this example, first thing that we want to do is plot the picture. So M is 4, 7. So 4, 7. That's M. A is 9, 2. T is 2, negative 5. And H is negative 3, 0. So if we connect it and make it as neat as possible, again, we want to list the properties off to the side so we know what we're dealing with and so that we remember them. It's got all the properties of a parallelogram. It's got 4 right angles, and it has diagonals that are congruent. So, again, when we start our proof, we have to write a plan. What are we going to do? So you're going to write out, I will use 6 distance formulas to show the opposite sides are congruent and the diagonals are congruent. That's our plan. So now your work is going to be the actual work. So your work is going to be the 6 distance formulas. And we're going with opposite sides and diagonals. So if I look at the picture, my opposite sides are MA, that's opposite, HT or TH, it doesn't matter what order. We're also going to do the opposite sides of HM and TA. And then we want the diagonals. I'm going to do the diagonals over here. My diagonals are HA and MT. If I draw them in, there's one diagonal, there's the other. So now for these, I'm going to do the distance formula. I'm going to write the distance formula once up here. You could write it for each one. I'm going to run out of room, so I can't fit it in. but each time you write the distance formula down, you have a better chance of accidentally memorizing it. Now, I'm going to stop recording for a minute and actually do these 6 distances. I'd like you to try them as well, so please hit pause. Okay, so I just finished all the work, and if we look at what my work showed, here, side MA is 5 radical 2, and so is, I can't see what those, HT. So these two opposite sides are equal. Now, if I look at my HM and my TA, those opposite sides are also equal. Then if I look at the work for my diagonals, and again, I simplified all my radicals. You don't necessarily have to. You could have left them here without simplifying them. So now if I look at my work shows that the opposite sides are congruent and the diagonals are congruent. So now I have to write a paragraph, and yes, I know it is annoying, but I would take annoying over difficult math any day. So what we're going to write is, since the length of MA and TH are the same, they are congruent. Since the length sorry there, that says the length of HM and TA are the same, they are congruent. A quadrilateral with both pairs of opposite sides congruent is a parallelogram. MATH is a parallelogram. Since the diagonals HA and MT are the same length, they are congruent. A parallelogram with congruent diagonals is a rectangle. So MATH is a rectangle. Again, I know this seems ridiculously annoying because it's not English class. However, you're going to pretend when you write your conclusion that a non-math teacher is grading your work, so you have to explain to them that your work is showing what sides are congruent, and you have to explain to them that when the opposite sides are congruent and the diagonals are congruent, the shape has to be a rectangle. Little side note, if your formulas do not work out, you made the mistake. If you are asked to prove a rectangle or a parallelogram or any other shape, it has to work. So if you get incorrect answers, you made the mistake, go back and check your work. Again, any questions, please ask me in class or email me.